Thank you, Bryn. Welcome, everybody, this fine Thursday morning. Thanks for spending your time with us here at Code Central. Today, we're going to be talking about the new code that's coming up. And first off, a little about me. My name's Steve O'Malley. I'm a lead engineering consultant with Efficiency Vermont. I specialize in commercial new construction, large multifamily new construction. I have become sort of de facto code expert over the years. And what else can I tell you? And building science, I'm an absolute nerd for. So those are sort of the things that I'm into. Efficiency Vermont, including myself, we are not the code police. We are here to help interpret the code and provide our best guess as to what code interpretations are, but the final say resides with other folks that we'll talk about in a little bit. Before we get going, there are a few housekeeping things I need to attend to. The first is to give credit to ICC, the International Code Council, that all the material contained today is proprietary to them and copyrighted by them. The information copyrighted has been obtained and reproduced with permission, and the ICC and ICC logo are trademarks of ICC. And what else can I tell you? Code book 2020. So the new code, I know I wrote 2023 CBs here, so you can tell I haven't updated my slide. It's going to be the 2024 CBs now. It's based on the prior code, the 2020, which followed the 2018 IECC. So the new code is going to follow elements of the 2021 International Energy Conservation Code. There is also select language updates and some more stringent requirements that have been laid out by Vermont that are included. And then also information from ASHRAE 90.1, the 2019 version for energy standards for buildings except low-rise buildings. Okay, so target effective date. Again, haven't updated my slide. The 2024 CBs will likely be effective on July 1st, 2024. And similar to previous codes, it's the permit application date which determines what version of CBs is going to apply. And a permit in this context is limited to a building permit or an Act 250 permit. So things like sewer, stormwater, other permits that can be associated with new construction are not what triggers when code applies. And so why are we going through another code cycle? Didn't we just have one, right? We're on 2020 right now. We're going to be going on to the 2024. And one of the reasons why we're having these code updates every 3+ years is to reduce greenhouse gas emissions per the state of Vermont's energy plans. And what this graph is sort of laying out for us here is that if we look at the orange slice of this pie, which is thermal, that's us. That's the building community. And you can see that in around 2025 that we're hoping, the state is hoping that we achieve a 26% reduction in global warming. Let me see if I can read this. 26% reduction by 2025 below the 2005 levels. And then you can see by 2030, we're looking to be 40% below that. And so to achieve that, we've got to do things like have buildings perform better. And here we are in the code cycle. And so, if we do the math, here we are 2024, where we've got 2 more code cycles, including the one that would be probably the likely 2030. So we still have a little bit of work to do to get our buildings to be using even less energy and thereby producing less carbon emissions. Similar to the old code, the stretch code, there is none. So there's just the standard code, and then we'll call it the points plus the package plus point system. And Act 250 commercial construction projects follow just the regular old 2024 CBs. Chapter 1, title change, is now just administration. State and local roles. Not much has changed here, but it's something I just want to highlight for people. That the Public Service Department is the entity authorized with creating and updating the CBs, but ultimately they do not enforce the code. Vermont employs a self-certification process, and no current code official is designated in code language. And the Natural Resources Board does not enforce the code for Act 250. So that sort of should raise the question, so who does enforce it? And ultimately, it's a self-certifying code, and entities like Efficiency Vermont are here to help try to interpret code. And if this ultimately needs to be resolved by somebody, it ends up going to Barry Murphy at the Public Service Department, even though on paper they're not the ones who are the code enforcers. So exceptions, Historic Preservation Office, they can provide exemptions, excuse me, from specific sections of the Energy Code. And there is some paperwork that goes along with that. It's not like they can just wave of their hand, say, ignore these parts of code. You've got to actually state your case and have your I's dotted and T's crossed to be able to get those exemptions. Cities and towns can elect to inspect and enforce town compliance. And so a question around that is, do we see that? Do we see cities and towns adopting different standards from CBES, at least as stringent? And I'm going to go back to that. And the answer is yes. We have seen cities like South Burlington develop and use form-based code. If you look at the new city center, you can see that in effect, that there's a emphasis on a lot of glazing on those buildings, particularly at the ground level. So cities and towns do have the option to do that. I think town of Heinsberg, on the residential side, was requiring that all new construction homes be made to the stretch code, if I remember correctly. And so that's again another example of a city or town using a more stringent standard. Let's see, what else? Oh yeah, Act 47, the Building Energy Code Study Committee. This was convened by the 2023 legislature, and it was to address issues related to declining compliance rates. Surprise, surprise, in a land where you have self-certifying code, that as code gets more and more stringent, that fewer and fewer participants are complying. And so the state called what's this, Act 47. And what do I have here? Including the potential designation. Here's the big thing. So one of the big things that's coming out of the study is that we need to have code enforcement if we want code compliance. I know it's shocking, but that was one of the conclusions. And one of the things that came out of that was looking to potentially designate the Division of Fire Safety in the Department of Public Safety as the statewide authority, having jurisdiction for administration, interpretation, enforcement, in conjunction with their existing jurisdiction over building codes. And the committee does recognize that there would be a need for funding and for training for this, because this is something that would be in addition to what the DFS is already doing. What else could I say about that? The Building Energy Codes Study Committee is also looking at whether or not they should include non-energy benefits, such as public health benefits and the cost of carbon, and how that impacts the affordability of housing projects. And recognizing that a lack of statewide building code impedes progress, risk of failure if builders don't know how to correctly construct. So the committee is taking on a lot of problems that need to be solved if we're going to improve code compliance, but also continue to build buildings in a safe and durable manner so that we're not creating problems for ourselves. Oh, so I had a bunch of bullets here. Yep, as part of this as well, they have to evaluate the current cost effectiveness for both codes. So that has to play into the count. And I think that's all I'm going to say about that. Okay, scope general requirements. Some scope sections. The language now includes, old language just said calls for code to provide minimum energy efficient requirements for the design, construction, and a plan for operation and maintenance. It now includes the language renewable energy and energy storage in there, and we'll touch more on both of those concepts a little later in the morning here. What else? So this is something that's now called out in writing. I can't remember if it was or not in the previous one, but so there's a section in the scope and general requirements that does talk about alternative materials, design, and methods, and it just explicitly stating that the Public Service Department has the authority to approve those written applications. Construction documents. So something that is now called out, it's in the language here that's in red. So all you architects out there, so your drawings, it's now a code requirement to indicate the air barrier on your construction drawings. And you can see the rest of the language there. That was in the existing 2020 code. Some definitions. So again, here we get back to authority having jurisdiction. It makes a point of calling out who doesn't have jurisdiction. So here we go. It says, for purposes of this code, neither the PSD or the DFS should be considered the authority having jurisdiction. And the same thing under code official, it says the same thing, that neither of them should be considered as the authority having jurisdiction.
Hey, Steve, we have a question.
Yeah.
Joe asks, will the Act 47 enforcement also be effective in January, or sorry, let me start again. Will the Act 47 enforcement also be effective July 1st, 2024? I know the fire marshals are not happy about this at all. They're already underfunded and understaffed.
I can't, well, never say never. I can't imagine it would be, because I don't think there are so many things that would have to be identified at this point in time and funding allocated to a higher staff, to train staff. So I can't imagine that would all be pulled together in the next 5 months. And as Joe is pointing out, yeah, DFS, they're not happy about this. They've already got enough to do, in their opinion, and that they are feeling that probably feeling underfunded for what they're already doing, never mind being asked to do more.
And that's it for questions for the moment, but I'll let you know if anything else comes in.
Great, thanks, Bryn. Something else in here, where there is conflict between rules adopted by the Division of Fire Safety and this code, those adopted by the Division of Fire Safety have preemption over the energy code. And that makes good sense. Life safety should take precedence over energy. The more general definitions. Oh, this is a nice one. The old language there that you see in blue, talking about semi-conditioned space. Semi-conditioned space was conditioned by a heating system whose output capacity is less than or equal to 14 BTU per hour per square foot of floor area. Most people aren't just randomly knowing that piece of information early on in their design. And so the new language just says an enclosed space within a building that is not a conditioned space, but is directly or indirectly mechanically heated or cooled. I think it just makes it easy, rather than somebody having to do some math and to really understand the heating system, et cetera, et cetera. I'm a big fan of this change. All right, let's hop in on commercial energy efficiency.
One question about definitions.
Yeah.
So there's a definition for semi-conditioned space.
Yep.
Is there a definition for conditioned space, particularly a quantitative measure for heating cooling capacity needed to satisfy the definition?
Good question. I don't know. I will, at the end of this, Brent, if you could just jot that down, I'll make sure to look it up at the end of the.
Absolutely.
Yep. Then we'll come back to that one. Yeah, that's a great question. That's an obvious question that I hadn't considered. Okay, commercial energy efficiency. So we have our prescriptive package plus point system for achieving and demonstrating code compliance, but there are other ways you can demonstrate code compliance, and one is using the ASHRAE um, modeling pathway. And so for those of you who do this, just please know that some of the compliance path now has new building performance factors. And as you can see there, what's in green was in 2020, and those performance factors are in blue on the right for the 2024 CBES. CBE certificate and affidavits. So we're all familiar with this. This is the one from the 2020 CBES, and it's got information up at the top where you're just sort of discussing building address, number of stories, square footage, et cetera. And then below that, we get into what are the compliance methods. And then you can see sort of the credits, those enhanced credits, numbers 1 through 10, that you'd have to have a couple in there, et cetera. Just want to know that there are a couple things that will change slightly to this affidavit. And so one is that now the thermal envelope details are going to need to be included. And that just is sort of following what Arby's does now. There'll be some sections talking about, gee, what is your wall assembly? What is the roof assembly? And I haven't seen the new certificate, but my understanding is it's not going to be onerous, that it's just going to be a small section. We'll now have to include the results from air leakage testing on there. And we'll get into this later on, but an indication of the solar ready zone and other requirements of this C402.5. And so solar ready zone, et cetera, we'll definitely get into that as the morning progresses here. So getting to condition space for building envelopes. So I know I'm calling it highlights, but these are just changes. So all U value requirements have been updated, and say that there's better alignment with the RBs when we're talking about multifamily buildings, those group R2s. It's not perfect, but it's close, and it's better than it has been in the past. I know the dream coming into this code cycle was to try to have sort of the grand unified theory for multifamily buildings, so that it was absolutely seamless between the two codes, regardless if you had a 3-story or 4-story multifamily building. But that proves challenging, and so we don't quite have it, but things are better, and we'll talk about some of that here. An indication of the solar ready zone, and so let's see some example assemblies. Oh yeah, this is something else that I like. That in the 2020 code, the way that the language was called out. Well, I'll just bring up the table here. So first off, I'll walk you through the table. So here we go. In the blue, we've got maximum overall U value for the 2024 code. And in green, in the little column in green, I put what it was for the 2020 CBs. And the way the language used to read in the 2020 code was just maximum overall U factor, as you see for those blue columns. And then for in that right-hand column that's white, they didn't say that they were examples. They just gave a U value, or excuse me, R value as an example, but they never called it out as an example. And many people were left with the impression that, oh, that's the assembly that I have to build. But it really wasn't. You didn't have to meet that R value requirement. You needed to meet the U value requirement. And so they did change the language up in that right-hand column that now says example assemblies meeting U factor requirement. And that just cleans that up, so that people are just aware that build the assembly you want. As long as it's hitting that U factor, you're all set. But here are some examples to give you an idea of what it's going to look like. And as we can see, looking down through the table, comparing the green column to the blue columns, a couple things. the U value for the insulation above deck. If you're like me, if you just stare at the U value, that doesn't really mean much. So it's nice to be able to refer over to the example assemblies. So for instance, that's now an R45 above deck, and the previous code was R40. Metal buildings, again, a slight increase in the U factor there. What else are we looking at? I mean, a slight decrease, excuse me, there. Attic, mass wall, metal building. So you can see, excuse me, that the U factors for all assemblies for roofs and walls have gotten a little more stringent. And similarly, when we look at below grade walls and mass floors, and we look at slab on grade floors, the big thing that I want to point out, which there should be clapping and applause in everyone's kitchen, office, wherever you happen to be paying attention to this training today, is I want to direct your attention to unheated slabs. If you look over, actually, you know what? I need to back up real quickly. I want to point out something that's new to this code, is that when we're looking at that column in blue or in white, that you're going to see that there are two columns, and one says R2 occupancy classifications. And so that's where it's sort of it's calling out those multifamily buildings to say, this is what the requirement is for the multifamily building. And then you'll see that in that middle column in blue, all other occupancy classifications. So they've made a point to call out the multifamily building so that it's going to be really clear what needs to happen for multifamily buildings, and again, to get it more closely aligned with RVs. But back to this unheated slab. In the previous code, unheated slabs were required to have R10 insulation beneath the entire slab. That didn't matter if you had a 4,000 square foot slab or a 150,000 square foot slab. And it had been raised on a number of occasions to the Department of Public Service that, whoa, you get these really, really large buildings, it gets really expensive to put foam underneath the entire slab. And really, how much benefit are you getting at the core of that slab? Meaning, if you're in 20 feet from your frost wall, how much good is rigid insulation doing underneath your slab other than just adding significant cost? So the folks that wrote the code backed off on that. And so for unheated slabs now, it's back to what it used to be, except the R value is increased. So now it's R20, but you only have to do it for 4 feet. And so that 4 feet could either be down the frost wall, or it could be coming in horizontally underneath the slab. So that's a great. I just want to applaud the folks who write the code for taking those comments into account and realizing that, yeah, that probably isn't a cost-effective solution.
And Steve, when you get a
Yeah,
good breaking point, we do have a couple questions that have come
sure,
in.
right now.
So going back to the conditioned space question, if it's not conditioned, how can it be mechanically heated or cooled directly or indirectly?
Let's go back to the. Where did I have that? So semi-conditioned space, an enclosed space within a building that is not a conditioned space, but is directly or indirectly mechanically heated. Not a conditioned space, but is directly or indirectly mechanically heated or cooled. I would love to hear other people's comments, because I've quoted what the exact language is, but I agree. I mean, if you think of, if something is directly mechanically heated, wouldn't you consider that conditioned? I'm not so good thinking off the cuff here. So that'd be another one that I'd be happy to try to scratch my head over and see if I can come up with some examples. And again, there are a lot of smart people that are on this training this morning. So if anyone's got an idea or an example that they want to share, please put that in the chat.
Thanks. Next question is blower door or air leakage testing going to become a prerequisite for all CBES compliance.
We'll get to that.
Great. That's later on. And I think regarding some of the most recent slides we're going through, Steve, does it, for U factor, does it mean if I can meet the maximum U factor without continuous insulation, will that be acceptable?
In theory, yes, but I think what you're going to find is with the U factors, it's almost impossible to do that unless you had an incredibly thick wall. Because I was sort of playing with that game because the code has some nice tables in there that sort of allow a user to kind of quickly identify, gee, is my assembly going to meet code? So it has a table, across the top is the continuous insulation value, down the X, the vertical column, it's talking about cavity insulation and framing thickness, etc. And you can cross-reference the two, and you can see, oh, there's my U value. And I remember walking away thinking, I don't know how you build a building now without continuous insulation and have it meet. And I'm talking about wood frame. If you've got a steel framed, 100% of the time, you're always going to have continuous. You won't be able to meet it otherwise. But for a wood frame building, I think it's now, I couldn't get a wood frame. I couldn't get a traditional wood frame building, meaning a 2x6. Even if it was chock full of spray foam, I don't think that was going to make that U factor.
There was one guess about the semi-conditioned space and mechanically heating it. Colleen suggests when the heater is in the basement but can't actually be ducted to the space, that might count.
Right. So you've got, your basement, which isn't, you've got an unfinished basement. You got your boiler down there. It is mechanically heated, but not conditioned. Right. You don't have active distribution in that space. Thank you.
Yeah, thanks, Colleen. Jeffrey has a question regarding underslab.
Yep.
The change to the underslab insulation appears to also eliminate continuous insulation under a heated slab. Is that correct?
No. So if you look at I'm going to back so I get that red out of the way. So if you look at the bottom row under heated slabs, if you look at the example assembly meeting U factor requirement, it's R20 for 48 inches below. So again, you've got to have R20 coming down your frost wall, and then it says plus R15 underneath the full slab. So that's what that language means there.
And that is it for the moment.
Okay, great questions. Keep them coming. Oh, what do we have here? So the old code looked like this, except the two columns there was maximum overall U factor for conditioned space, and then what is now the example assemblies, that used to be the semi-conditioned space. So the semi-conditioned space now has its own table. And here again, I'm not going to read through them, but you can see that the U factors from 2020 to the 2024, that the U factors have increased, which means that it's gotten a little more stringent. And similarly, there are the example assemblies over there on the right. And you can see that, again, and it makes sense, it's not as stringent as it is for a conditioned space. For instance, an unheated slab is saying R10 for 24 inches below. And for a heated slab, it's maybe something got cut off there. R15 for 24-inch below. I would still think if you were heating the slab that you would put stuff beneath the entire slab, but maybe not. No, it looks like that's the actual language that was in there. So again, this is the semi-conditioned space. And slides will be made available to everybody. I'll send out a PDF. So, if I'm going through slides too quickly, fret not. PDFs will be sent around. Something else nice that the code does is defining better defining liner systems and filled cavity assemblies for metal buildings. Seems like I would get a call every 3 months about a metal building, and then I always have to remind myself what is the terminology and what do those assemblies actually look like. So they've added some language to help those of us who aren't working with metal buildings. And I'm not talking about steel frame building. I'm talking about, like, big metal, like a hangar or Butler buildings, those types of things. Again, added some language to describe double layer continuous insulation. And similarly, on walls, they've added some definitions to help just make the code more readable, more digestible. This is another change that I really like as well. So we're talking about tapered above deck insulation. And I'm going to let you read that. But what I'll say is that in the old code, it was not called out how you were supposed to calculate the R value for a tapered thickness roof insulation. And if anything, I think it referred to an area weighted R value, because the real answer is, if you had a tapered roof insulation and it was 6 inches on one end, and well, actually, I'll just make up a number. It was R20 on one end and R40 at the high end. Mathematically, you and I just say, well, the average is R30. Well, that's the simple math. The actual physics involved isn't linear like that. It's something different. But the code didn't really offer any help in terms of how to go about calculating that, because it's complicated. And to just demystify it and not worry about getting into the minutia, they're just now saying, you know what, just take the average value across that tapered roof, which I think is great. I applaud the code folks for making that change.
Steve, before you go much further,
Yeah.
one question, maybe for the previous slide. As with similar code revisions, can you give us some validation or justification for the new U factors? In the past, it has just been a random number because of your graph of goals to get to the 2030 carbon reduction.
Yeah, so going back, looking at these tables, so there are competing interests here. One is we've got an interest of saving energy, reducing carbon, and the other is we got to make buildings affordable to build. You can't just start throwing more stringent requirements at a building without consequences on the cost side. So the committee that actually does the rewrite for the energy code, they have to demonstrate cost effectiveness of their recommendations. And there hasn't been a lot of, from what I've seen or heard, there hasn't been a lot of pushback on the commercial side. On the residential side is another story. I believe there's been a lot of contention over what's perceived to be cost effective and what added costs are going to be to construction, et cetera. So I guess from the validation standpoint, please know that the folks that are doing this work they're required to look at the cost effectiveness of it. And as they're making their recommendations to the Department of Public Service Department, that all has to be clearly laid out and an argument made for making these kinds of changes.
Yeah, thanks, Steve. And obviously there's quite a bit of public engagement that the Public Service Department goes through, legislative committee on rulemaking process. So all of that goes through its own public review.
Yeah, no, that's great that you mentioned that too, right? For all of you who are on here, it's an open, transparent, public process that you can participate in. So there are stakeholder meetings to discuss and talk about these ideas and concerns. And so next code cycle, by all means, if it's something you're interested, you should be vocal and be present and be part of that conversation.
Yeah. So in addition to not being code enforcement, we also don't draft or, we don't adopt the rules ourselves. That is at the state level, state agency level.
Correct. Another good.
We have a question
Okay.
from Doug. Can you define the C and F in the U value column?
Yeah.
And in addition to that, why is the 2023 foundation listed as 0.434 and not 0.0434? So maybe we'll start with the first one. Define the C and F in the U value column.
Yeah. You know what's funny? C and F are the same thing as U values.
That's not confusing at all.
Not confusing at all. So just look at it as a U factor. And then someone with those keen eyes, Doug, the answer is that the guy who created this slide didn't put a 0 there in front of the 4, and that would be me.
Well, good catch. We've got somebody very astute and good eye for details, so we will make sure to update that slide. So thank you so much, Doug.
Thank you. Yeah, I don't want you to walk away with the impression that the code went backwards on. Well, actually, let me think about this. The number is still wrong, but it would be a less stringent number in general just because of the fact that it's no longer required beneath the entire slab for that unheated slab. But the numbers are clearly not correct.
And we might want to also double check the final rule because just to confirm accuracy.
Yep, I agree.
You might not. Yeah, you might be pulling what's in the final rule. So we'll just make sure we're cross-checking that before we update our slide.
Yeah.
And that's it for the moment. Thanks.
All right, thank you. We got through that. We talked about tapered insulation. Okay, and so getting back to roof insulation above the deck. And I'm seeing here note that they had different language regarding the minimum R value for tapered roof insulation and low pitch slope roofs with continuous insulation. And again, I love it when they clean things up and make it more simple. And here they are just saying that any roof has to have a minimum of R12 at its lowest point, regardless of if it's a tapered roof or a low pitch slope roof that has untapered insulation. Just got to make sure you got R12 at the lowest point. Done. That was another question that seemed to come in frequently. Was around things like roof drains and whatnot. But again, still need to meet the average R value requirement for the whole roof. So you may say, hey, I'm only going to put R12 because that's what code said. I only need R12 my lowest point, but you're still going to make sure you're hitting that average R value across the roof. Framed floors that are exposed to ambient conditions or structural slab insulation shall be installed to maintain permanent contact with the underside of the subfloor decking or structural slabs. This is when I think of this, I'm thinking of picture a parking garage on the first floor and then either commercial and mixed use multifamily above. What we typically see is if you're down in that parking garage, you look up and you're looking at the underside of the pour deck for that first floor. And then you've got a suspended ceiling that's going to keep plumbing and whatnot warm. And typically what we see is spray foam around the perimeter on the concrete on the walls of the garage, and then batt insulation installed on the back side of the sheetrock that's suspended. And there's an air gap typically between the fiberglass and that concrete pour deck. And so this exception 1 is essentially still allowing for that. And that's really, I think, what I want you to walk away from this. Or excuse me, exception 2 is what I was just describing, that there can be an airspace And I think that's just allowing for the complexity and challenge of insulating that space in those parking garages. It's you're hanging sheetrock and then you're kind of just stuffing bats up in there as you're going along. It's not an exact science. Um, Fenestrations. So similarly here, we're just going from, I thought there was going to be something about multifamily buildings in here, but I'm not seeing. Oh yeah, it is in there. Okay, so a couple of things in this table that have changed. If you're looking down the left-hand column under U factor, you're now going to find categories like storefront fenestration. There was no category for that in the 2020 CBs. And similarly, operable fenestrations for Group R2, which again is your multifamily buildings. And that's a good one to call out because I I was always a proponent of if you were constructing a multifamily building, you're you're building little houses. They're apartments, but they're little houses. And if we're building a house for someone, we would be putting in a better U value window. That's going to be a little more, it's going to provide a little more comfort. It's going to save a little bit of energy as well. The U value for the RBs in 2020 was 0.28, and tons of those windows are on the market at no cost higher than what it would cost for a 0.37 window, for instance. And so in this code, they're just saying follow RBs. And so you can see it's interesting that the U value for that window that you'll see there, operable fenestration R2 occupancy, in the previous RBs, that value was 0.28. And it's now a 0.3. And I don't know why they made a change. I think that might have to do with something like with aligning with Energy Star windows, perhaps. And so just to remain in alignment with Energy Star, they moved that U value to 0.3. Anything else of interest here? No, really, again, the big takeaway is just know that the U factors, other than that group R2, became slightly more stringent. And that storefronts got called out. So air barrier performance testing. So in the new code, air leakage shall not exceed 0.25 CFM per square foot tested at 75 Pascal. The previous code was 0.3, so it's a slightly more stringent requirement. And there is an exception, and that exception is group R2. And so there are two things around the exception here. One is that you test to 50 Pascal, and this is getting back to we're trying to, shouldn't say the code folks, whoa, what happened there? Code folks trying to unify RBs and CBs so that it doesn't matter if you're building a 3-story or 4-story, you should be kind of thinking of them the same way. And so an RB's building is tested to 50 Pascal. And so we're going to test all multifamily buildings, 3-story, 4-story, and more, all going to be 50 Pascal. Much more stringent air leakage number, and that number is 0.15 CFM per square foot. And so two things I want to say around that is it's great that this is now, it doesn't matter what size building you are testing, it's all tested to 50 Pascal. And the reason to test to 50 Pascal rather than 75 is that we've been testing multifamily buildings for a lot of years in this state. The entire building community, builders, developers, owners, contractors, are all pretty familiar with this metric of CFM per square foot at 50 Pascal. So if somebody says, oh, I have a 0.25 building, a lot of people who have been doing this for a while, all kind of nod at each other and say, yeah, I've got a sense for what that means for that building. And so to be able to not lose sort of that reference, to be able to compare to all the other buildings that have been going on, it was recommended that we use 50 Pascal to test buildings, and I agree with that concept as well. It keeps that common language in the community to be able to talk about these buildings. And that same sense didn't apply to commercial buildings because we didn't test them. Um, it's only been recently that we've started to see more and more air barrier performance testing done on larger buildings. And also, when you get into really large commercial buildings, it's imperative you're testing to 75 Pascal so that you can actually kind of get a reasonable reading. Um, so that's another good reason why the commercial buildings should be tested at 75. And the other reason they're tested at 75 is because that's what the rest of the the IECC followers are doing. So here's another exception around that air leakage requirement is that if you are so getting back, there was a guest who had the earlier question is testing required? And so the answer is yes. In the new code, testing is required, but unless you have a really large building, and it says larger than 250,000 square feet that do not include Group R or Group I occupancies, then you can test, or you have the option of doing commissioning, which was, if you remember in the old code, there was a checklist essentially that you would have to hire a commissioning agent, and they would have to be out there doing inspections and at certain times of construction and completing to verify the commissioning aspect. And here's another one exception is if it's unfeasible to test as determined by the Vermont Department of Public Service. And in that case, you can commission. So if you've got a building where it's going to be unfeasible to test, you can make the case for that and just petition the Barry Murphy at the Department of Public Service. Let's see. Here's a big change that I'm not necessarily a big fan of. In the 2020 code, let me back up for a second. Dwelling and sleeping unit enclosure testing. So in the buildings that were permitted under the 2020 CBES, there was a new requirement it's essentially called compartmentalization testing, where you have to test the actual apartment units. And you're essentially thinking of that apartment unit as if it was a standalone house. You were just hooking up a blower door to the corridor, and you're exhausting air from it, depressurizing that space. And it had to meet a metric of 0.35 CFM per square foot, tested at 50 Pascal. And it was a challenge on a number of fronts. First and foremost, a lot of people weren't even aware that that was a requirement. And that sort of sneaked up on them when they were in the middle of construction. And so it was certainly an achievable number as long as you're hitting the big things. If you look up and you're looking at the tub above you, you've got to make sure that penetration is all sealed up. Open web trusses, those could be challenging too, at that demising wall between units. But 0.15 is it's going to make people work a little more. This isn't going to be just let's sheetrock it and hope and see what we get. This is going to be, someone's going to actually have to probably be doing some progress testing to make sure that you're going to hit it come the final test. Some other things that were changed regarding compartmentalization testing is that they changed the number of units that need to be tested. I think it was something like before it was 10% of all units, and now they made a distinction that if it's a small building, fewer than 8 units, you have to test all units. And if it's more than 8 units, you do 20% of the units. And I thought I had something that I was going to say exceptions, and the answer is no, there aren't exceptions. So those are that's it for compartmentalization testing. Here's something that's new for 2024 is operable openings interlocking. All that's getting at is that if you've got a door that's greater than 40 square feet, that there's going to need to be some type of control that interlocks with the heating and cooling system, so that when the door is opened, it might be based on a amount of time that the cooling set point has to be raised to 90 degrees and the heating set point has to be lowered to 55 degrees. And there are some exceptions, separately zoned areas associated with food prep, warehouses with overhead doors, the first entrance of vestibules. So that's a big change that I think is that's going to catch some people unawares, but not you folks who are sitting here today. Okay, solar ready zone. We talked about this earlier. This is a new requirement as well. And so this solar ready zone, as we mentioned earlier, is something that has to be shown on the drawings for the project. And it's located on the roof. And here you can see that I should say if it's located on roof, or no, it is. I think the definition is it's the solar ready zone located on the building. So it's buildings oriented between 110 and 270 degrees of true north, or if it has a low slope roof, it could be anywhere on there. Let's see, it's got to be not less than 40% of the roof area. And again, this just has to be identified on the roof. It's not that you're installing solar today, it's you're identifying where there's going to be a space for future solar to be installed. And it doesn't have to be one large space. It can be subzones on the roof. So if you've got rooftop equipment that makes sense to have strategically located, you're not going to have to move your RTUs around to make your solar ready zone one contiguous space. So that the area can be divided up. So those construction drawings will need to indicate the roof load specified, show interconnection pathways for conduit. So you can picture that part of the construction is to make sure that the conduit is in place to get to the roof. No wiring has to be installed, just the conduit has to be in place. And that there needs to be an area for electrical energy storage system. So it's essentially, the way I read this is you're going to have a mechanical room or another room dedicated that's going to say, this is where there's going to be where there's going to be space for, again, thinking into the future, energy storage systems, and the utilities like the GMPs of the world are thinking about things like flexible load management so that energy can be stored during times where, say, a lot of renewables are online and producing energy, and that energy can then be used during peak times or when, again, the sun drops. And on the electric side, the main panel shall have reserve space to allow installation of the switching equipment for future solar. And again, that will fall on the electrical engineers out there. And so as it seems like there's a lot there, there's always some exceptions. If you've already got on-site renewable energy, if your solar ready zone is shaded 70% of the daylight hours, then yeah, it's not going to make any sense to have a solar ready zone. Similarly, if incident solar radiation available is not suitable, so again, if you've got, whatever, high voltage lines next to you that are creating small shadows on your rooftop, etc. Similarly, extensive rooftop equipment. So if you've got, and I'm not sure, it says rooftop equipment, skylights, vegetation, other obstructions certified by licensed professional. So that one, I guess, is open to a little bit of interpretation. I'm going to leave that at that. Okay, chapter 4. Bryn, any more questions on shell stuff before I move on to mechanical systems?
Not yet, and if anybody prefers to raise their hand and ask a question, we can take you off mute too. But nothing's coming in right now. We can always come back to it.
Okay, great. Okay, so ventilation. Meet ASH rate 62.1. That's what we've always done. And the exception is multifamily buildings. So multifamily, and it calls it out, multifamily buildings see the ventilation requirements in RBs. So again, just trying to make sure that we're standardizing the requirement between the two codes. And I'll tell you right now, for multifamily buildings, it's heat recovery or energy recovery ventilation is now required by code. It's required by the RBs, and so it'll be required for buildings that are 4 stories and taller as well. Fault detection and diagnostics. So buildings greater than 100,000 square feet will require monitoring of HVAC performance. And so there need to be permanently installed sensors automatically identifying faults, and that will also notify personnel. And this is interesting to me. So it shows that I'm not that familiar with these systems. Automatically provide recommendations for repair. So just FYI. So exceptions to this are group R1 and R2 for this fault detection and diagnostics. Total system performance ratio. It creates an alternative compliance method for some HVAC systems. I haven't worked on it. I've been doing this a long time. I haven't worked on a building where someone has approached me and said, this is how we're looking to demonstrate code compliance. But if you're one of those people, please know that there is some language around that. Equipment sizing. Heat pump equipment shall not be sized greater than the calculated peak heating and cooling loads. So it's calling that out. What do I want to say about this? So air source heat pumps are exempt from temperature setbacks just because of the way they operate and how they operate most efficiently. This requirement is really getting at the heart of that. When these units are oversized, they become significantly less efficient, and not just less efficient, but they also will tend to short cycle more, which means you're driving the equipment pretty hard, which means you're probably shortening the life of the equipment as well. So not only are there some energy benefits to right sizing, but there are also some durability and investment benefits. Similar along those lines, outdoor condensing units that are serving multiple indoor heat pump units, those need to be sized equal or less than the total capacity of the indoor units. So again, getting at that, we need to stop. Doesn't happen in all cases, but we see plenty of instances where that outdoor piece of equipment is oversized. Equipment efficiency tables. So the efficiency tables for mechanical equipment were all adjusted to meet the federal standards as per IECC 2021. Nothing was moving beyond that. We're just following the national lead there. For those of us who have seen air source heat pump equipment and heat pump equipment reported in efficiencies in terms of SEER or HSPF, which is heating seasonal performance factor, there are new testing protocols, and so there are new reporting protocols. So now you're going to see those numbers reported as SEER2, and HSPF2, just adding a 2 to the end of that. And the numbers are slightly different. I don't have my head wrapped around it yet because I haven't had to yet, but at some point in the near future, I'm going to have to get a better understanding of how the two relate, because again, I have a sense in my head of what a 17 SEER piece of equipment is, or a 8 or a 9 HSPF piece of equipment is, but what is a 8.3 HSPF2 piece of equipment? How do the two compare? I don't know yet. Maybe that could be a future training. So increases in efficiency. So there are a couple of pieces of equipment out there that the efficiency did increase compared to the old code. Those are PTACs, packaged PTHPs, which are packaged terminal heat pumps, room AC units, and similar. Non-ducted furnaces had a slight increase. They went from 80% efficient to 81. Floor-mounted AC and condensing units serving computer rooms. It's pretty niche, but just letting you know. But most equipment remain the same. Chillers, boilers, heat rejection equipment, VRF, AC, and heat pumps. All those efficiencies remain the same. And they have added a few new tables. So again, it's stuff that is not the most common of equipment, but they have added equipment following the IECC, and just it's probably good for the people who are doing some of these things. Some indoor pool dehumidifier equipment. I'm just going to scroll through these quickly because it's just more just to know that these things exist now. Electrically operated DX DOAS units, single package remote condenser without energy recovery. Water source heat pumps, or I thought we had water source heat pumps in the old one, but now it's got its own separate table, I guess. Heat pump and heat recovery chiller packages, ceiling mounted computer room AC equipment. Okay, hot gas bypass is back on the menu. So there was something that was in the code in 2015. It went away in 2020. And this is just saying cooling systems shall not use hot gas bypass or other evaporator pressure control systems unless a system is designed with multiple steps of unloading or continuous capacity modulation. Some more notes on heat pump supplementary heat. The old code, it used to just say during times of defrost. And now it's saying it applies during the following. The vapor compression cycle cannot provide the necessary heating energy to satisfy the thermostat setting. The heat pump is operating in defrost mode, only for buildings that require heat for health and safety. And in those cases, if the vapor compression cycle malfunctions or the thermostat malfunctions, then electric supplementary heat can be used. So they just kind of cleared that up and added a little more language. Automatic start and stop equipment. Let's see. Control shall be provided for each HVAC system with DDCs of individual zones. I'm not going to get into that here. But again, one of those things, just please be aware of this. Demand control ventilation changed slightly. I don't have notes of what it used to be, but so demand control ventilation required for spaces. I'd say it right there. Just more. It used to be. It's gotten more stringent. So the occupant load reduced from 25 to 15 people per 1,000 square feet. Okay, so it is all right there. All right, and the exceptions language is more clearly defined for DCV. And there was a bunch, so I'm not listing it all here in this slide, but just be aware of that. Parking garage ventilation. It used to just be carbon dioxide. Now nitrous oxide compounds have to be detected as well. And there is an exception for some garage ventilation systems that don't utilize any heating or cooling. So the exhaust capacity less than 4,000 CFM, or the garage area to ventilation system motor nameplate power ratio that exceeds 1,125 CFM per horsepower. So anyway, just be aware that there are some exceptions, and to be sure to look at that as you're designing your buildings.
Thanks, Steve. Question from Joe.
Yeah.
Do you know if there will be an applicable date in terms of pre-permitting design? In other words, in 2024, if the 2024 CBs will be effective July 1st, is that expected to design to that starting now or starting July 1st, 2024?
Right. Good question. So if you have your building permit in place before July 1st, you will design to the 2020 CBs. If your building will be permitted after July 1st of 2024, you should be designing to the new code, if you're aware of that already.
Okay, thank you.
Yep. Okay, where are we? Ventilation, air, heating, control. So non-transient dwelling units shall have ERVs. And so it's now calling out, it used to be that, so non-transient dwelling units. So this is really sort of getting at multifamily buildings here. And it's saying that the ERV needs to have 60% recovery efficiency on latent energy, that's the cooling side, and 70% recovery efficiency on the heating side, or what's called the sensible heating load. And it says here, exception, systems with a minimum sensible recovery efficiency of 75% at 32 degrees at design airflow. And I think what that's saying is, if you have a really efficient, if your if your heat recovery ventilation system is really efficient on the sensible side, meaning on the heating side, then you don't have to have an ERV. I think that's what this is saying. Otherwise, you have to have an ERV. And I guess they just wanted to allow a little bit of leeway so that if somebody was really, really insistent that an HRV was better for their building than an ERV, that you can do that, but it has to be a slightly higher efficiency. Ventilation controls for things like hotels, so unoccupied guest rooms, the ventilation turnoff time is decreased from 30 minutes to 20 minutes. Fan efficiency, so there's a new fan energy index rating. That again, this is coming from IECC. That's nothing that's coming from folks in Vermont. Some exceptions to expand to include specialty end uses. A low capacity ventilation fan minimum efficiency requirement was added. I think that's what I'm going to say about fans here. Refrigeration equipment. So we're talking freezers, refrigerated freezers, walk-in coolers, walk-in freezers, refrigeration equipment. So there are new efficiency requirement tables updated to reflect, again, IECC. There's a bunch of them. I'm not going to present those here, but just again, be aware if you're doing work with commercial kitchens, et cetera, that there are new standards for the efficiency of the refrigeration equipment. Some changes to duct and plenum insulation and air sealing. Supply and return air ducts. The insulation now is R12 for insulation where it's in an unconditioned space, and that used to be R8 in the 2020 CBES. And if you have ductwork outside of your building, it's now R20 compared to, it used to be R12 for the 2020 CBES. Service water heating. High input service water heating system equipment size now defined. That's 1 million BTUs per hour or greater. That's just a change. It was just something that struck me as odd that the previous code had a section talking about high input service water heating systems, but never talked about actually what that meant. So they actually have the language in there now. Electrical power and lighting. So your dwelling, sleeping units, etc., 100% LED lighting is required. And that doesn't mean they have to be fixtures. You could have screw-based fixtures, but the screw lamps have to be LED. Parking garage lighting has new lighting control requirement. And I'm not sure why I don't have any more information written under that bullet. I'll look that up and add what that piece of equipment is there. In general, the lighting power density became slightly more stringent, approximately 15%. You know, when I was just sort of doing this, looking across all the different spaces, but it varies by building area or space by space type. Some is greater than 15%, some's less, some's right around there. Escalators are required to perform energy recovery when resisting overspeed in the down direction. I'd love to. I wish we were all in a room and I could see a show of hands of the number of people that have had an escalator installed in their building in the last code cycle. Automatic receptacle control. So we're thinking about offices, stuff like that. 50% of electrical receptacles in offices, conference rooms, print rooms, break rooms, classrooms, etc., shall be controlled. Energy monitoring is now required in buildings greater than 25,000 square feet. And I'm not sure how much more. I might dig back into that a little bit more to see if there's more in there about the requirement around what that energy monitoring has to look like. But just know that if you got a commercial building, there's an energy monitoring component now. They cleaned up the electric vehicle charging station section, which is great because that was always another head scratcher for a lot of people calling in with how many pieces of charging equipment do I need and what kind? Because the tables were just a little squirrely in that regard. And now it's level 1 is not going to be it's a level 1 or level 3, which is the lowest. I can't remember off the top of my head. So must be level 2 chargers or better. revised requirements for charging stations and future ready capable spaces. So we'll get into the chargers here in a little bit. Electric readiness. So electric readiness for future electric space heating, electric water heating, electric cooking equipment, and electric dryers. And again, the exception is the multifamily buildings. Those R2 buildings may get points in the point section for including electric ready systems. So you'll notice it's saying electric readiness for future electric space heating, electric water heating, electric cooking equipment, etc. So you could still do gas if you wanted to for various systems, but it's paving the way for future electrification of those spaces. I talked about this briefly before, interior lighting power allowances. I think in the interest of time, I'm going to just move past this. Just know that again, there was about a 15% increase. All right, 15% became 15% more stringent. Occupant sensor controls. This is a new requirement for spaces that are smaller than 300 square feet and enclosed by floor-to-floor ceiling height partitions. Those will now have to have aux sensors on the lights. Dwelling electric meters. Each dwelling unit located in a group R2 building shall have a separate electrical meter. That's nothing new, but the new exception is for low-income buildings. So buildings where a majority of the living units serve tenants at or below 80% of area median income. So if you're an affordable housing provider, that's part of what's trying to keep units affordable for tenants, is making sure that their utilities are known. So this allows for the affordable community to roll utilities into the rent, which then they're required by law to, they can only increase a certain percentage on an annual basis, kind of a thing. Oh, I did get it a little bit here. Energy monitoring. Equipped to monitor, record, and report energy consumption. Exception, R2 occupancies in individual tenant spaces, provided that each space has its own utility service and meters and has less than 5,000 square feet of conditioned floor area. So that exception tells me that if you are of a market rate multifamily building, you don't need to do energy monitoring. But if you have a master metered multifamily building, so again, you're the affordable community, you do have to do energy monitoring on that building. That's how I read it. And so the stuff that needs to be monitored, the total HVAC system, interior and exterior lighting plug loads, electric vehicle service equipment, any process loads, building operations, and again, other miscellaneous loads. So that's the language that's in the code, miscellaneous loads. So again, it's going to be self-certifying code, but that's up for someone to interpret. All right, so here's the new table for determining what you need for electrical vehicle power transfer infrastructure. And it has just sort of cleaned this all up. In the past, there were two tables that had to be referred to, and you were to do some math, then take 50% of that number and install that, and then have the other 50% just sort of electric ready. So that just got cleaned up. So here it is based on occupancy type. It is clear that it says, here's the percentage of electric vehicle service equipment spaces there need to be, how many EV ready spaces there need to be, how many EV capable spaces there need to be. And then there's this equation. And again, in the interest of time, we're at 8:47. I want to keep moving. So I just want big takeaway for today. It's been cleaned up. It's easier to figure out, what are your needs for charging equipment. Okay, good. I'm glad I put these definitions here. So level 1 charger with a charge rate of 1 to 2 kVA, no longer permitted under 2023 CBES. And that's pretty much just like plugging into your 120. That's what, if you've got a plug-in hybrid, that's what you can do at home. Just plug it into your wall outlet. Level 2 chargers. Yep, that's now the minimum charge rate requirement. And an electric vehicle fast charger is also referred to as a level 3 charger. A little bit of definition here, because they just always keep talking about EVSE. An EVSE space is an automobile parking space that is provided with a dedicated electric vehicle service equipment connection, meaning the equipment's there. EV ready space, it's a parking space that's provided with a branch circuit in either an outlet, junction box, or receptacle that will support eventually. So you're essentially putting in the infrastructure that someday the charging equipment could just be hooked up. And then an EV capable space is that all the requisite infrastructure has been brought to within 5 feet to allow installation of future electrical wiring and connection to get there. So a few splitting hairs a little bit there, but at least, when we go back to our formula, that equation 4-1 that you see right immediately below the table, and you look at those percentages above in the table for EVS spaces, ready spaces, capable spaces. They've done a nice job with this code revision to spell it out and help people determine what they really need. What do I want to say here? I don't think I need to say much about that. And again, I'm just doing this because of the interest of time. EV ready spaces that exceed minimum requirements may be used to meet EV capable spaces requirement. This will all be in the slides. You're going to get the PDF. So you'll have this all at your fingertips. So there are some new exceptions. Parking facilities serving occupancies other than R2 with fewer than 10 automobile parking spaces. Standalone retail stores with fewer than 50 spaces. You're still required to provide an EV ready and EV capable spaces if there are more than 10 parking spaces. Motor liquid fuel dispensing facilities, like gas stations. Here's another exception: R2 occupancies with multifamily building, garage, or covered parking. And that's coming right from the fire life safety folks, is that they do not want charging equipment located directly underneath the living spaces in a building for fear of fire. I think if you've got an above ground parking lot in addition to your parking garage, I think that surface parking lot that's outside the building would still need to comply, I think. More on that. Additional electric infrastructure. Exception: buildings with R2 occupancies. I don't have anything. Okay, I am going to talk a little more about this. So buildings with low capacity combustion space heating. Condensate drains have to be installed within 3 feet of heating equipment. And so this is just, again, some more clarification language. Dedicated branch circuit installed and labeled for future heat pump space heater. So this is getting back to that requirement that in the drawings, et cetera, that you're going to have to indicate how the building is going to be able to be electrified in the future. That's what this is all getting at. So you could be running gas today to be heating your space, but in that mechanical room, if there's going to be future equipment that's going to produce condensate, you've got to put the drains in today. So again, additional electric infrastructure requirement: buildings with high capacity combustion space heating. Conduit only between the junction box and then within 3 feet away from space heating equipment and an electric panel. So again, just putting the electrical equipment so that future electrification can take place. And junction box, conduit, bus bar, and electric panel shall be rated and sized to accommodate a future branch circuit with sufficient capacity for equivalent electric equipment. I read that and it tells me there's going to have to be some additional engineering that's done on buildings at the very front end, so that even if you're building it today with gas in mind, you're going to have the design in place for that future electrification, so that the construction can actually proceed, so that this equipment is installed, so that it can be electrified in the future.
Steve, a couple questions.
Yeah.
Regarding additional electric infrastructure, do you know if there are any rules regarding exterior heated pools?
I don't.
Um,
I don't
and
remember seeing anything about exterior heated pools, but I could take another cruise through.
yeah, and any questions that we're not able to give a definitive answer on, we'll follow up with you.
Yeah.
That's it for the moment.
Okay. So other combustion systems with similar circuit and signage requirements as for combustion heating. So again, that service water heating someday will be electrified. Um, Commercial cooking appliances will someday be electrified. Clothes drying, if it's gas again, someday electrification. Um, and same thing here we go. This is getting into our multifamily buildings, residential clothes drying equipment serving multiple dwelling units. So those those common area laundry rooms in multifamily buildings.
Steve, for some of this electrification ready requirements, just as a question of do these panels, conduits for future electric systems need to be installed from day one and essentially sit empty until that future use?
Yeah, I mean, if we go back, so looking here, this is language I pulled right out of the code. So I wanted to make sure that was the first one. Yeah. So condensate drains need to be installed. Dedicated branch circuit installed and labeled for future heat pump space heater, unless a large enough circuit already exists to serve the cooling equipment, the existing cooling equipment. So the branch circuit have to be installed and labeled. This is saying for here, it says conduit only between the junction box and the space heating equipment and electric panel. Junction box, conduit, bus bar in electric panel shall be rated and sized to accommodate a future branch circuit. So yes, those pieces of equipment have to be sized from day one.
Okay, thank you.
Yeah. Or as I read it, that's how it seems that way to me. And then some labeling requirements. And so we talked about that. Additional efficiency, renewable and load management requirements. So buildings shall comply as follows. So this is for buildings greater than 1,000 square feet. Comply with the additional energy credits requirement. Buildings greater than 2,500 square feet, you comply with the additional energy credits requirement. That's nothing different compared to 2020. But then you see the big and comply with additional renewable and load management credits. And so similarly to the energy credit system that we're familiar with from the 2020 code, there are now similar tables and a la carte that you can choose from renewable and load management credits. And similarly, it's based on building occupancy group type, and the point system has changed. And so you at first look, you should gasp and think, oh my God, the number of points I have to obtain is so much more than it used to be. Well, it's just different because what I'll show you in a second, the table of all the energy credits that you can choose from are all worth different numbers of credits as well. So don't be initially scared here. Mixed occupancy buildings that you just calculate a weighted average of credit requirements based on the square footage of floor. And so here's what the new energy efficiency measures and credits table looks like. And you can see there are a lot more energy credit measures to choose from. So you're going down the column to the left, and then you can see based on building occupancy type, how many points you would get for each of those measures. So, and if we go back here, and for instance, if we look at a group M building, it says energy credit requirements 75. And if we come over here and we look at group M, we can see that, gee, if you have a UA reduction, that to me means I think you're talking about slightly better wall assembly or roof assembly and windows, etc. You get 28 points right off right out of the gate for that. If your heating equipment efficiency is, I can't remember what the percent efficiency better is, but is better, you're getting 29 points. So you can quickly get all the points you need. And it's interesting. I see under energy recovery group M, 242 points. That might be a typo by yours truly, but I'll have to go look at that. So you could get all your points just by doing energy recovery, apparently, from that table. But anyway, just know that the table's in there and that has changed. And so here's the old, excuse me, and here are even more. So we've got essentially, a good 24 or so of these energy credit measures that you've got to choose from. And we've only got a couple minutes left, so I want to quickly get to what are the exceptions here? Core and shell buildings and build-out construction that does not have final lighting or HVAC systems installed under a prior building permit have reduced credit requirements. Unconditioned parking garages in certain groups, portions of buildings devoted to manufacturing or industrial use. But then here's the thing that's interesting to me is this renewable and load management credit requirement. And so again, there are point requirements by building type. And so real quickly, I just wanted to say, here are some of the things: on-site renewable energy, lighting load management, HVAC load management, automated shading, electric energy storage, cooling energy storage, solar hot water energy storage, building thermal mass, insulation embodied carbon. That's a new one. Really in the big picture of, again, if you think of the code cycles, the heart of it is trying to reduce carbon. Well, they're actually baking in, it's a small amount of points, but it's still points if you're choosing low embodied carbon materials. And then additional electric infrastructure. And some exceptions: buildings that achieve additional 70%. So if you achieve an additional 70% of energy efficiency credits, then you can ignore the renewable and load management credit requirements. Or excuse me, you can't. All right, hang on a second. Only 50%. Got it. No, let me backtrack. If you achieve an additional 70% of energy efficiency credits, then you only need to meet 50% of the renewable and load management credits. If your building achieves an additional 120% of energy efficiency credits, then you don't need any renewable and load management credit requirements. So there's some flexibility on the design side how you want to go about doing that. And then buildings that are between 1,000 and 2,500 square feet do not need to achieve the renewable load management credit requirements. It's 901. Actually, that's pretty much it. There's really nothing new here. Existing buildings, they added some vertical fenestration language. Just saying that meet the table in the commercial code, in the new construction piece. That's it. We landed the plane 1 minute over. Thank you all for being here today. We'll get back to you, Brent. I'll let you close us out here.
Yeah, great. Thanks so much. For those that are still with us, there's a very brief 4 or 5 question survey after you log off. If you can just give us your quick feedback, that'll help with the additional webinars we have signed, logged, and planned for the next 6 months or so. If you registered for this, you are automatically registered for the next monthly webinar, so no need to register again. You'll get reminders for those. If they comes, because it's Zoom and not Teams, you'll get an email from Zoom, and within that there's a link to add it to your Outlook calendar or your Google Calendar. I suggest doing that so you have it saved. It is a little bit of a manual process, but this helps us with tracking registrations a little bit more easily. And for anyone that asked for AIA credits or certifications, I will be submitting those on your behalf, and I will get the certificates out probably early next week, since we have quite a few folks that joined us on the call today. If there are any additional questions, I'll put my name in the chat, and you can reach out to me. Other than that, I hope you all have a great day. we'll, as mentioned, we'll follow up on questions that we were unable to answer during the call, and get back to you individually. And yeah, don't hesitate to reach out with additional technical assistance questions. If you want the 2020 CBES code books, hard copies of those, we have those for reference as well. And all of that support is free of charge. So have a great day, have a great rest of your week, and thanks so much, Steve.
Yeah, you're welcome. Bye all.
Bye, everyone.